Welcome, everybody.
Howdy.
Hi. Let's get started. It's exactly 2:15, so it's time to talk about row-level security. So first, thanks to everybody for coming out to see this. This is a lot more people than I thought would attend, so I'm glad to see all the interest in this topic. Before we get started, I'll tell you a little bit about me and why I'm here talking to you. So I work at Tableau. I worked at Tableau before, and then I left, and then I came back. It's what we call a boomerang, if you haven't heard that term before. But I think people in this room probably understand better than most that Tableau is a pretty unique place with a special culture, and I found that I kind of missed it when I left. So I came back to take on the role of product manager for our data services, of which row-level security is going to be one of the major features that we're working on. In non-work related activities, I'm an amateur charcutier, and I have about 25 pounds of bacon curing in my basement fridge right now, along with a leg of prosciutto that is about half eaten, because a whole leg is a lot of prosciutto. And when I'm not at work or cooking, I enjoy riding bikes down mountains, and I've only broken 7 bones, so I'm doing pretty well. And here's what we're going to go into detail on today. First, I want to talk about the basics of row-level security. And for people who haven't dealt with it a lot before, this will be kind of an intro to what people do today to implement row-level security in Tableau. And there's a lot of different strategies and a lot of information out there. So I'm going to do a quick survey of what exists today. Then I'm going to talk to you about Centralized RLS, which is the working name of what we're in the process of building right now, and talk you through the design, what principles we're using to build it, and what sort of features we're going to be implementing, as well as the various scenarios that we'll enable with it and how they'll work related to what's possible today. Then I've got a little demo to show you an idea of what that could look like, and we'll finish up with some time to hear from you. I'm interested not only in any questions you might have, but feedback. I'll keep reiterating the point that this is a work in progress. We're actively developing these features, and so you have a chance to give us feedback on, does this look good? Is there something that we're not thinking of? Do you have an interesting use case that we need to consider? So I'll leave time at the end for that, but I'm also at the conference through the end of the week, so you can contact me through the app or in person if you want to talk further on this. So what is row-level security today? Well, first of all, we have to define what row-level security is. So I'll start with a basic definition for the people who are not familiar with it. Row-level security is when you take your data and you implement security at the row level. Yes, so it's not that complicated. But this differs from a lot of security methods in that you're not determining who has access to a certain resource like a database or a table. You're allowing them to query the table, but the result set they get back can depend on a lot of things. It can depend on their identity, where they're querying from, the kind of query they're making, the tool they're using, what network they're on. There are all sorts of different reasons why you might want to give someone access to a database, but not everything in that database. And there are a few other strategies like that. There's column-level security, which is security applied to your database at the column level. Then there's level of detail security, which is with regard to how far down you can go in terms of drilling into details. Maybe I can see the aggregates, but I can't see every individual row. So there's lots of different ways that you can do query time filtering of the data based on who's making the query. Row-level security is probably the most relevant right now and what we're going after first, but we definitely are looking at a more broad security picture for our data services in general. So in order to make row-level security happen, you have 3 different things. Well, 4 if you count the data. You have data somewhere in your org, and then you have some policies on that data. This is what you use to set up the rules that determine who can see what. The next thing you need is you need to know who's making the query. What's their identity? Where are they querying from? What tools are they using? Whatever's the relevant information to enforce those policies. Then you enforce the policies at query time so that when the results come back, they're filtered appropriately to whatever that user has access to. And these three different parts can happen in different parts of your data ecosystem. And that is a lot of the variability in the solutions we see people using in Tableau today. The first type of RLS I want to talk about is RLS in the database. And lots of database vendors provide row-level security functionality in their own systems. These are just a few. You've probably used others. But the database vendor themselves is going to give you the ability to do the policy, determine identity, and filter the data when you're querying that database from anywhere, from Tableau, from some other client, from an app. The nice thing about this is that it's implemented way down at the very lowest level, so you know it's always going to be applied whether or not you're coming from Tableau or any other system. Now, the downside of this could potentially be that, sure, if you're just using one database vendor, you can do it all in their system. But how many people use multiple database vendors that may not have systems that work together that cohesively? So a lot of times you'll find yourself implementing the same policies or similar policies when you have to use data from multiple databases together in the same query. So this can be hard to set up and hard to keep in sync. And we'll keep coming back to this point of keeping these policies and the security in sync, because that's where most of the security problems come from. When you're responsible for manually making a change across a number of things, inevitably, someday something will get out of sync, and then you have a potential security hole. So how does database RLS work with extracts in Tableau? Now, the caveat here is when you make that query coming from Tableau to your SQL server or whatever, the data is going to be filtered when it comes back. So when you build that extract in Tableau, the data is already filtered. And all the extract is going to contain is the data that you were specifically allowed to see when you made that query. And this may be fine. This may be exactly what you want. You want to just store your view of the data. The trouble can be when you want an extract that anyone can use, because now the security has already been applied, and there's an unsecured extract of just the data that you could see. So you really can't share that if you're using database RLS. The other biggest, most common way we see people implementing RLS in Tableau is through user functions. And there is a lot of detail on this. I'm not going to go into every possible aspect of the use case, just a handful of slides. But for anyone who isn't aware of the white papers section on our website, you can go and search for row-level security white paper. And there is a very extensive paper written by a friend of mine and several other people that goes through in great detail how to do this with lots of examples and different aspects of how you might implement these user functions. I'm going to go over it at a high level, but please go read more if this sounds useful to you. So just like before, we need policies. And these policies are generally in the data itself. So it's not a separate rule you say that user A can see this data and user B can see this data, but rather you have what we call an entitlement table. Some of you may be familiar with that term. It's a sort of generic term for a data source that maps identities to entitlements. And entitlement means you can see this particular set of data. That could be based on a specific row. It could be based on if a field equals a certain value. We'll look at some examples of how that works in a few slides. Then you need to determine the user's identity, and this is done through Tableau. This is where the user functions come into play. You're using functions like username or isMemberOf that refer to the Tableau identity of the user who's viewing that viz. And then the filtering happens in calcs or data source filters. So you use the username function to define a calc that you can then use to filter the data. Let's take a look at how this would actually work. So you have data that may look like this. And I've got, let's say this is a list of sales that our company has made. And you have the name of the person who made the sale and the amount that it was. So when I say that the policy is in the data, that means that the policy we want here is very simple. If your username is the username in the name field, you get to see that row. And we'll go much more complex than that, but this is the sort of the simplest case. So then I would write a very simple function where I say, if the field called name equals the current logged in username, then return true. So this function returns true if my name is in the name column and false if not. Then I add a data source filter that only keeps the rows where this function returns true. So now, whenever anybody looks at this particular data, they're going to only see the rows where their name is in the name column. So there's a few things to consider here. One is this is only as secure as that function. So if I have access to the data source itself, then I can just go in and edit this function and say, if username equals Sanjeev, show me everything. If I have the ability to remove that filter, I'd be able to see everything. So this requires you to keep the data source with this filter and this policy in it protected and not allow people to download, copy, or edit it. That's why these have to be data source filters, not filters in your viz itself, because then someone can just go into the viz and edit the filter. So this does limit your ability to share these data sources. If you want to have a data source that anyone could download and modify for their own purposes, this is not going to be secure for you because they can just remove any of your filters. So keep that in mind when we're talking about the user functions in general. These have to be implemented at the data source level, and those data sources have to be kept secure. Now we're going to look at what entitlement tables do, because generally your data is not quite so simple as everyone's username is in the rows that they have access to. If it is, great, you're done, but generally you're going to have to do something more complex. So in this case, we have similar data. There's sales information, but there's a region column as well telling us what region this sale was made in. And we don't know who has access to what based on this table. There's no identity in there. There's nothing to build a policy out of. So we bring in the entitlement table in this case, where we say certain sales managers have access to a certain region. That's the policy implied by this table. So now we can join these two tables together on the region column, and we'll end up with the sales manager field mapped to all the rows that they have access to. Then, just as before, we would make the user calculation, filter on that, and we're good. We have successfully mapped from the username to the region to the data in our fact table that we want them to see. Generally, you're not going to be even that lucky that you have one level of indirection that can solve the mapping for you. You may end up with something more like this, where here we have a list of sales in the orders table. Each sale has a customer. Each customer is in a region. Each region is owned by a regional manager, and we have a table that maps from regional managers' names to IDs. So we have to go through several levels of indirection in order to get that mapping from the user's identity to the rows we want them to be able to see in the orders table. But you can extrapolate from this as much as you want. Ultimately, what we're doing is producing a single table that produces that mapping and expresses that policy that we wanted to apply. So what are some other considerations when we're using user functions? One thing is, as I mentioned, you can't share these data sources that you've made with these policies in them because that would allow people to remove the security you've added. So you're probably going to have to make a lot of these. And they may have overlapping policies. If you wanted, for example, to make access to that orders table joined with the customer contact information, and you wanted to make another published data source that's that orders table joined to geographic information about shipping, and you wanted to make another data source that's orders table joined to information about the salesperson and their career performance. You have several separate data sources that all need to have row-level security policies built into them to restrict access to that orders table. And this brings us to the maintenance problem I mentioned before. Now, if you come up with a change that you need to make to that policy or to that entitlement table, you're going to have to go to each of these data sources and make that change separately. So this can be risky. Whenever you have to do manual work multiple times, there's always the chance that something won't get copied right or that you might leave one out. But even if you're perfect, what if someone else is using the orders table in a published data source and they don't even know that you added these security rules to all the other ones? Someone else may be able to give differing access to that table if they also have the credentials to the database itself. So this isn't just about making a mistake. This isn't just about a malicious user going in and deleting your filters and trying to get at the data. It could just be a lack of coordination. And this is a risk of democratizing data. This is what we want people to be able to do. We want them to be able to go out, get access to the data, and share the insights and the vizzes they create. But it's more and more important as we give people access that we have security that is always applied and not up to each individual person to know that they have to do it themselves. So I mentioned that you have to disable downloading of these data sources, and you have to make sure that there's no way somebody could ever disable the filter, edit the user calc that you're using. All of these things have to be very locked down. And finally, let's talk about extracts. Extracts work a lot better in this case than they did with the database case because you took that entitlement table and put it into the extract itself when you did the extract. So now, whenever anybody queries that extract, they're going to have to go through that policy that you made based on that entitlement table. And so they'll get the filtered data back. So this is great. This means now you can publish this extract to a server, you can share it with people, and you can know that they're only going to be able to see the rows that they are allowed to see. There's another aspect of this strategy that's important to think about. It used to be a really big problem, but things have gotten better in the last couple of years, and so it's less of a concern. But you can imagine when I'm talking about joining together, especially several levels deep, you've got your fact table. Your fact table could be thousands, tens of thousands, hundreds of thousands of rows. You have a list of hundreds of users in your organization. You have potentially tens of entitlements per user for different databases. You might have a few extra dimensions that you need to join in to make that graph I showed you. So now you're talking about this massive combinatorial explosion when you materialize the final table that you're going to filter on. This used to be a big issue, as you can imagine, because you ended up with these multi-million row tables that you had to then filter. Databases have gotten much, much better at this. So a lot of databases will optimize to do the filtering before the joining, so you never have to build up this giant table and materialize it in one place. Same for extracts. You don't have to extract millions and millions and millions of rows since we introduced multi-table extracts in 2018.3. Now you can take your fact table and your entitlement table and put them both into the same extract without having to join them together. So this is still something to consider just in terms of complexity of your entitlement table. If you're joining together many, many, many different tables to get that entitlement table, even if you're not then crossing it with your fact table, you still could end up with some pretty large and difficult to understand entitlement tables. So sometimes you may want that complexity because you have a very complex case. Sometimes you may not. There are examples of both strategies in the white paper I mentioned. So definitely, if you want to go down that road, you can read a little bit more there. So what are we looking to improve about all of this? I mentioned some pros and cons of these different strategies, and I should mention there are many, many other strategies. I actually cut a couple slides of strategies that are very uncommon and I have to go into a lot of detail on. Check the white paper, they're all there. There's different solutions for using parameters, using custom SQL, doing embedded apps that have vizzes in them. If you're interested in seeing some of the more technically advanced ways of doing it, definitely check the website. But among all of these, the ones I explained in overview and some of the other ones that we've seen out in the wild, there's the problem of having no single point of control. So if you're using one database, that's your single point of control. If you're not, you have to spread across multiple databases. If you're using one published data source, that's your single point of control. But who uses one published data source? You might have many that are all used in different ways. So being able to enforce that policy in exactly one place and make sure that everyone querying the data has to go through it is very important and can protect you from a lot of the risks I mentioned. Having one source of identity can also be a big issue. And of course, in the modern world of SSO, we have a lot of solutions for identity management, but not everyone uses those. There may be problems that prevent you from doing that. So you may have to deal with the fact that if your SQL Server and your Redshift databases are not using the same source of identity, you have to do some sort of federation to figure out how the user should be expressed to each of those systems when you make a query. And finally, a single point of auditing is very useful. You want to be able to see who got access to what. So if there is a policy error or security risk, you can tell what happened and go fix it. So being able to go to one place to look at your one security rule, your one set of policies, and all the different people that went through it can be very valuable. Next is the question of authoring and maintaining policies. In an ideal world, you want to write a policy once and have it applied every time. You don't want to have to write the same policy multiple times for different ways of accessing the same data. The example I gave a few slides ago of using that orders table in many different ways, you still probably want to secure it in the same way every single time. You want those policies to be easy to maintain. You want to be able to look at them, understand them, make changes, see how those changes will affect people, and understand the impact of any security policies that you're implementing. You want to make sure that they're always applied and can't be bypassed, that there's no backdoor to get to the database. There's not someone who you had to give the credentials to that then you forgot because they needed it for some special case and that was 2 months ago. And so now they have the credentials to go straight into the database without going through your policies. Or someone gets a hold of a data source because they just want one little change, so you send them a copy, but then they can delete the user filter and see all of the data there. So the pattern we're seeing here is centralization. And so after 25 minutes, I get to the first word in the title of the presentation, centralized RLS. This is the problem that we are trying to solve right now. We're trying to avoid all those issues that come up when you can't have a single centralized point of enforcing your security across your entire Tableau ecosystem. So I got to put in a disclaimer for a minute here. This is all work in progress. This is something we're building right now. So even the words I'm saying, centralized RLS may not be the name we take to market. The demo you see, the designs you see, may not be what ultimately ships. But this is something that we're in the process of building. I want to know your feedback about what you see here today so we can make any changes we need to as we're developing this. And what you're going to see will ship in multiple stages, which may include things that aren't here. Some of the things may come sooner and some of them may come later. We're targeting in 2020 to ship the first set of functionality for this, and then be able to follow on to that with more and more functionality and richer types of security like the ones I mentioned before. So that aside, let's go back to my 3 aspects of RLS. The way we want you to be able to do this when you're dealing with implementing your security in Tableau is define policy in Tableau, determine the user's identity in Tableau, and filter the data in Tableau. Now, this doesn't mean that everything has to be done using Tableau tools. Like I mentioned, there are things like SSO, SAML, other identity providers that you can bring in. There are technologies in the underlying databases that you can bring in. But just as Tableau becomes your central point of control for visualization and analysis, it can also, if you want it, become your central point of control for policy enforcement. So let's see how this would work. The main concept that we're building to represent this is what is currently within the development team called a publish connection. I don't know that that's what it'll be called when it goes to market. We, of course, will have a lot of conversations with people who think about good names for our features. But you can basically think of a published connection as representing only the connection to a set of tables in a database. It doesn't know anything about modeling. It doesn't know anything about calcs. All it does is expose tables from a database. But what's important here is that this becomes the point where you can apply your policies. A table can be exposed from the database once to anyone who wants to use that table. Multiple published data sources, multiple vises, and all of them will go through that same security policy. So these policies also would abstract the connection to the database itself. You don't need to give people username and password to the underlying database because it's their Tableau identity that's going to determine their access through these policies. So the published connection can store that credentials to the database itself, and you don't have to worry about prompting people for credentials, sharing credentials with them, or creating individual accounts for everyone within the database. So now, as in the previous diagram we looked at, a query comes in, the policy is applied, the results are filtered, and they come back. None of that core concept has changed. What's changed is the level at which these tables are exposed. They're not implemented down in the database where Tableau is unaware of what's going on. So you can get all the optimizations, you can get all of the availability in various Tableau tools like catalog, prep, all of those. And they're not way up in the model or the viz where you're worried about sharing them with other people. This is one object that exists out in your Tableau ecosystem for people to use, but they don't have access to modify it or get around your security policies. And the nice thing is, no matter where this data is queried, it all has to go through that policy. There is no other way, unless you wanted to make another way. We wouldn't stop you from doing that. But in general, you would want to have just one way to access that data. So any embedded data sources, workbooks, ask data conversations, prep flows, anything that accesses that data is going to go through your single point of control. There's no duplication. There's no risk of accidentally leaving the policy out or implementing a change incompletely. And there's no need to change the way the policy works depending on how the table is being used. So I'll give you a quick architectural overview of how we're making this possible. We're working on data services. Again, name in progress. We don't know what these will ultimately be called. But the idea is that all of the Tableau apps go through the data composition service, which sits above the query service, which exists much as the query pipeline does today. But the difference here is that every single query has to go through that policy service you see off to the side. Data composition service is constantly checking to make sure that policies are being applied to the right queries. So as you look, there is no other way for any of the Tableau applications to get direct access to the database without going through this single point of control. And it may be that you have no policies on a particular data source or query. That's totally fine. It'll just go straight through there without any filtering. But there's no way to bypass your policy if you do have one. So let's talk about those policies. If you're familiar with the Tableau expression language, if you've been writing calcs, we want you to be able to easily write policies as well. We don't want these to be arcane statements that you have to learn some other language to deal with. It's also important that they be easy to understand and audit, because the easier it is to understand the policy, the less likely it is to have an unintended side effect or a consequence that you didn't expect when you wrote it. It's also important for us to make sure that these policies can be created visually, I mean, this is Tableau, but also automated. So the policy service and all the other services in that diagram will have APIs that you can use to rapidly apply variations on policies to many different data sources without having to do them all one by one. And also, it's going to be important to have parameterization, because perhaps you have similar tables, but the column names are slightly different. We don't want you to have to write a different policy just to have a slightly different name, but to be able to have one policy that applies to both with just a slight parameter change of that column name. So these are some of the principles that we are keeping in mind as we design the policies. Now let's go through and talk about some of the scenarios that we want to enable for people and how those might look in this centralized RLS system. So first, the simplest is not even based on the user. I've talked a lot about user-based policies, but I mentioned back at the beginning, there are a lot of other things that you may want to enforce a policy on. Like in this case, you don't want anybody to ever be able to see inactive accounts in your database. They shouldn't ever show up in Tableau. So you could make a statement that says if the account status is not equal to inactive, then show it. So you'll only get the active accounts no matter who's querying it. So you could do this with just a filter, and probably that would be fine for a lot of data. But if it is absolutely imperative to your security stance that this data not be visible to anyone, this would allow you to have that centralization and auditing that I mentioned earlier. So let's get a little more complicated. This is the same example I showed earlier. We're restricting the rows based on whether the salesperson is the current user. So in this case, if someone who's in that table queries the data, they can see their rows. If I query the data, I can't see anything. I get back nothing, which is correct. I'm not in that table. You also could use the isMemberOf function, which if you're familiar with calcs, you may have used before. This is a way to tell if the currently logged in user is a member of a certain group. So in this case, we have that access to these rooms is determined by the team someone's on. So maybe I could say that everyone in my Tableau identity system is a member of the everyone group, and then they're a member of one or more other team groups. So with this single policy, everyone can see the rows with everyone as the role. And if someone is a member of an additional group, they'd be able to see those rows as well. Now let's go into how entitlement tables will work, because this is where things start to get complex, because we want to allow a lot of flexibility and possibilities for optimizations. So we look at the same data I showed the previous time we talked about entitlement tables, where sales managers have access to every sale in a region, and individual salespeople have access to only their own sales. So what you would do in this case is bring the entitlement table into your policy. And you can think of this conceptually as a join, but it's not actually materializing as a join at any point. There's not going to be a table that is the union of these two. So you may have something that looks like this, where you look up the values from another table to use in your policy. So we import the entitlement table. Then we specify the relationship between the tables. We say that the region column in one maps to the owns column in another. And then we specify that we want to compare the username with the sales manager field. So this is similar to the example that I gave you before, just in a slightly different policy language. And the results we would get of that are what you would expect. If you are a manager of the West region, you'll see all the West rows. If you're a manager of multiple regions, like Muna is, you can see all the rows from multiple regions. So we got the same results as we did before, but the difference is that these are applied at the table level, no matter where they're coming from, no matter how we access this data, join it with whatever else. Yeah, sir.
Dial back to that last slide real quick.
This one?
That one. I hit the stat button right as you
Oh, man, don't steal my pseudo entitlement language I made up.
Thank you.
No problem. All right. So now I want to show you how this might actually look. I'm just going to give you a small glimpse of some of the scenarios that will be possible. This is not meant to be an exhaustive demo. This is to get some of the user experience concepts we're playing with out to you for your thoughts, your feedback, and we want to see if this makes sense. Does this feel like Tableau? So I'm going to show a couple of examples, but there are many, many more things you can do to combine together multiple rules in different ways, give different people different levels of access, make compound policies. This can get as complex as you need it to serve the purposes of your security reasons. So let's close that and go over to this view that may look familiar to some of you. This is just a view of a bunch of connections that have already been made for me. And the nice thing about this, I mentioned with published connections that we can abstract the underlying credentials to the database. So if I'm looking at this, I know I already have access to all of these data sources because someone has already set that up. I don't need to worry about, do I have the credentials to the orders tables? If I can see it, that means I have access to it. So I'm going to click here on orders, and we see a whole bunch of tables in that database. So you can see there's a place here for security policies, and there aren't any yet. So let's go and create one. I'm going to add and edit a security policy, and this is one possible way the experience might look. I select that I want to control access to the following tables, orders, and now I'm going to build a little formula to determine how I want to gain access to it. So I can see that the orders table has an employee name column, and look, there's me. So I want to say if the username equals employee name, then show rows conditionally. So this is just a very simple way of saying only show the rows where the current username is the employee. And down here, I have this little preview. And I'm going to say, let's take a look at what I would be able to see if I access the data through this policy. And I can see only the rows that I have access to. Like, OK, that's cool. I want to see what it would look like to James Paxton. And he can see only his. Now, one important thing to notice about this is I'm not stealing anybody else's access when I do this. I'm acting, in this case, as an administrator of this database. So I have access to all the rows. If I didn't, I certainly wouldn't have access to be able to go into this system and say, oh, let me see James's rows and Alan's rows. That would be restricted further down in the system. So the only people who would be going through this experience are people who have the ability to see all the data anyway. There could be some interesting edge cases where someone who is responsible for creating policies does not have access to the underlying data. You could imagine in healthcare, just because I'm the security expert for our databases doesn't mean I can see confidential patient information. So that's one of the aspects of the user experience we're trying to figure out is how we could allow someone who can't access the underlying data to still build effective security policies. So this looks like the policy I want. I'm going to say that's done. Let's go through and create a slightly different policy in a different way. So I'm going to go back here, and I want to look at the employee quotas. And again, there's no security policies, so I'm going to create one. And this time, let's try to do it with a data diagram instead. Yeah. Oh, is it too small to read? Sorry about that. Let's see what happens if I make it bigger. We'll have to scroll around a bit, but hopefully this works better for everyone. I have now my employee quotas table. And you can see on the left here, these are all the fields that are available from Tableau itself. So I can tell who's a current user, what's their name, what's their domain, what are their groups, all of these things. And here are the fields available in my data. And there's no match between the two. I don't have a way to relate the username to the employee ID. So this is a perfect case to bring in an entitlement table. It just so happens there's another table in the database that maps from employee ID to employee name. So now I'm just going to drag a couple relationships between these tables. And OK, now I've said map from the Tableau user's name to the employee name to the employee ID field of my quotas table. So now when I go down to the preview and I say preview it as me, oh, I can still see everybody. That's weird. I have to pick which table I want this filter to apply to. So I'm going to apply it to employee quotas. And now you can see I only have one row, the row for employee ID 1, and that's me, which means if I go to someone else, I'll see a different employee ID. And so that's his quota. Again, I can see all this data because I'm an administrator of the database, not because this is some secret backdoor functionality. So that's great. Let's save this policy. This is working as I expect. And now I can see over here a textual expression of this as well. So this is something I could copy and paste into the open text of another one, modify it if that's what I wanted to do. So how would these policies actually work in the real world? I'm going to stop being the database administrator now and act as a typical analyst or creator. Let's go and look in Tableau Desktop. This is an experience everyone is familiar with. The tables and all the policies and everything I created exist on Tableau server, so I'm going to go in there. And for content type, there's a new one here, tables. And this shows me all of the individual tables I have access to across all the published connections that have been created. Orders is the one I happen to know I want, so let's connect to it. And you notice in the preview, I am the only employee name here. It shows all of my sales, but nobody else's. And again, this is because no matter how I access that data, how I query it, the row-level security is always applied. So that looks good. This is what I want. Now let's make a viz. I want to show a row for each employee's quota. This is a very simple viz. Just bring in the employee name, bring in sales, and here we go. We have a single row with the sum of all my sales. Now, I don't get to see the sum of anybody else's sales because I'm just one regular guy from that table, and I don't have any higher level access like I did when I was creating those policies. So still, this is the viz I want. So I publish it up to server, and I call up my coworker James and say, hey, can you look at my viz? I made this awesome viz to see the total of all your sales. So when James looks at this, and it's hard to see, but down in the bottom here, now we're logged in as him, he sees a totally different number because he's only seeing the rows with his name in them. But that's not the only policy there is. I also, in this case, skipped over building a policy where people at higher managerial levels can see broader sets of data. So now let's go to Kirk, the VP of sales, and we see we're logged in as him. He sees a row for each individual person with their sum of sales for all of them. So this is one viz using one data source that I shared with multiple people, and they all got different views of the data based purely on that policy I created. That's what I mean when I say centralization. There's no need for me to create different access for these people to the underlying data itself in the database. There's no need for me to create different vizzes for different levels of management. I can do this one time, and everybody gets the view that they want. So let's go back to some slides. Oh, my demo script, secrets. So now you know everything there is to know about row-level security. You know what people do today, the standard practices in the industry, and how people do it in Tableau. You know where to go to get more information. Go read some white papers. They're very deep and interesting. And you know some of the pros and cons of the current techniques that are available. Specifically, the shortcomings that have led us to want to build better and richer features for you to get more control and more security over your data. I also went over the design and architecture of centralized RLS, or whatever it eventually is called when we ship it, and some examples of scenarios and user experience that you may be able to use when that comes out. So that is my content. Thank you all very, very much for coming and listening to this. And please fill out a survey in the app. I know that some of you may need to stand up and leave, so now is your opportunity if you want to do that. And otherwise, we will use the rest of the time for any questions or feedback that you want to give me on this. So I'll give everybody a minute to shuffle up. Thank you.